Hey everybody, welcome back to Stats with Ahili. So far in this series, we have covered data types and the rules and symbols you'll use in R. Today, I'm finally getting to something genuinely fun, okay? That is vectors. This is one of those topics that once it clicks, a huge part of R just starts making sense, okay? Because, honestly, you are going to be using vectors in almost every single thing you do in R going forward. Okay, now let's get into it. What is a vector? As you can see here in my screen, I have written few things. Please read it with me. Basically, a vector is simply a combination of different numeric, character, logical, or any other data type values, okay, all stored together in one object. That is the thing. And you create a vector mainly with that C which we were using, right? That C is basically the concatenate function, which is written as like this, as you can see, this part. This is the function. Okay. Now, what is this? Every vector you have technically already been building in the last two episodes. That is C. This. Like I was talking about, right? If you have many elements, then you use C to bind all those values together. That is what I am seeing. I am talking about here. You have kept seeing, and that's exactly this. Okay. Now, what is vector manipulation? Vector manipulation is genuinely one of those most frequently performed tasks in R programming. Basically, R gives you a rich set of built-in functions and operators that lets you create, modify, extract, transform, and summarize vectors really efficiently. And these operations form the foundation of basically all the advanced data analysis you are going to do later. So today we are going to walk through the most useful ones. Let's start today. Okay? See, look at here. Our first segment today is basic indexing, and now I have called this vector. I have given a variable name x and I have put the function c. What is the c? That is a concatenate function. And what will the c do? It will keep those values together. Like if there was only one value, I need not use c. Okay, there are multiple values, that is why I'm using c here. Now look at here. For this vector, what are we going to do? What is this basic indexing? First, see, this is length. What is this length function doing? Length is giving or telling us how many numbers are there in the vector. Okay, let us see how. I am doing command plus return and I'm getting the output that is 8. 8 is what? How many numbers are in the vector? You want to check it? Let's check it. 1, 2, 3, 4, 5, 6, 7, and 8. So it is giving us the correct output, that is, it is giving us how many numbers are there in that vector variable name x. Now, what is this x1? X1 is giving you the value at position 1. Okay, what is the position 1 here? That is 1. So it will give you the output 1. Okay, and just to avoid any confusion, R starts counting from 1 and not 0. Okay, so let us see what it gives us. It's giving us 1 because in position 1, what is there, what value is there? That is 1. Now if you want to see the position, what value is there in position 6, then this will be the command. Okay, this is called indexing. Indexing is like giving this third bracket, this squared bracket. Okay, see, in position 6, again the value is 1. Let us see 1, 2, 3, 4, 5, and 6. And look at here, position 6 value is 1. So the output here given is 1. Now look at here. The next thing is x. And now I'm putting the squared brackets, the third bracket, and I'm putting the function c to bind the values 1, 3, and 6. It basically gives you, lets you pull out multiple positions at once. Multiple positions, that is position 1, 3, and 6 together. Let us see how it happens. See, for position 1, the value is 1. For position 3, the value is 2. For position 6, the value is 1. You have already seen. So this is how you can get multiple position values by this C function. Okay. Right. Now coming to our next segment, that is logical checks and the which function. Let me pull it up a bit. Okay. Yes, so now coming to the which function. You can directly ask R a yes or no question about every element in a vector. Okay. For example, see, x equals to 1 basically checks every value in the vector and tells you for each one whether it is equal to 1. Okay. Let us see this. Just a minute. Yes, so look at here. As I was talking about that x equals to 1 checks every value in that vector and tells you for each one whether it is equals to 1 or not. Now look at here in this vector, see, I'm calling it the output, and here it is true, false, 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 true, false, and false. Basically, it is checking where there is 1, it will come to be, the output will be true. If it is not 1, then it will be false. Okay. And if I am saying that x not equals to 1, it means that every position will be true where x is not equals to 1. X is 1 here, so it will be false. X is not 1 here, so it will be true. And this is how it works. Okay. Okay. So okay, I had this logical checks here. I'm sorry I missed it. Anyway, now coming to the which function. Okay, so now here's where it gets very, very useful. That is the which function, which basically does not just give you true or false, it gives you the actual positions. Okay, position or positions where the condition is true. And if nothing in the vector matches, say if it does not match, then it will give you an nothing was found. Okay, let us see what it gives us. See, for x equals to 1, where is the 1 present in that vector? It is in position 1 and position 6. Is there a 10 here? Is there a 10 here? It is not. But let us see that I want to know the position of 10 in that vector. Let us see what it gives. It gives us integer 0 because it means no match was found in the vector. Okay, no match was found in the vector. So basically that is all for the which function. Now coming to or segment 4, that is modifying values inside a vector. Now this is genuinely powerful. You can combine indexing with which function to directly replace a value inside a vector. Okay, now what does this mean? This basically means that here I am first trying this function, that is which, x equals to 3. This means that I want to change, I want the position of the values 3. Okay, in which position is there, and here I'm trying indexing with it. When I'm giving these squared brackets and giving a value 30, this means that it will replace the value 3 wherever it is present in that vector with 30. Okay, let us check that. First I am doing the command, that is x, which x equals to 30 with the value 30, x equals to 3. Okay, now I'm calling x and see. Look at here. Wherever there was 3, it has turned to be 30. Where it was 3, let us see. 3 was here. And now look at here. In the output, I'm getting not 3 but 30 because we have changed the command, right? And now I'm going to do the same thing, same example with x equals to 1. And I do not want 1, I want 100. Okay. So in this command, it will replace every value of 1 with 100. Let us see. Yes. So where was 1? It was in position 1 and position 6, right? Now it has got changed with 100 with this command. So this is also very, very useful in our programming. All right. Now that is all for segment 4. Now coming to segment 5, keeping or dropping specific elements. Okay, now look at here. I am keeping, I here I am writing x means, and here I'm using those squared brackets, the third brackets, which basically means that I'm trying to indexing it. So here I am saying x, c means I am having multiple values and I'm taking the numbers 1, 2, 3, 4. This means that these are the positional values. Okay, so this, if I'm going to run this command, this will just keep only these positions. I mean the values for only these positions. Let us see what happens. You do not have to trust me. You have the computer right in front of you and you can check it. Let us see. So yes, this gives us the values on the positions of 1, 2, 3, and 4. Let us check it. What were the values? Here, see. 1, 9, 2, and 5. And we have changed the value of 1 to 100, right? So next thing will be 100, 9, 2, and 5. These are the four first positions, because that is what we have written, right? Okay, now look at this command. Here we are having a little minus sign, and this minus sign flips it, okay, because this keeps everything except these positions. Like I do not want 1, 2, 3, 4 position values in that vector. Then I want to remove it, but how do I remove it? I just need to keep a minus sign in front of the C function. All right, so let us see if it really works. It really does work, because I do not want the first four. So let us see what happens. Let us see. 1, 2, 3, 4 is not given. 7, 1, 3, 6 should be printed. And here 1 is changed to be 100 and 3 is replaced with 30. So it will give us the new values. Okay, 730 and 6. All right. Let us come back. Okay, now here we have got only one value. Now look at here, for only one value, I am not using the C function because there is nothing to concatenate. So let us see here, x minus 3, it is the same idea, it just removes the single position, position 3, and just keeps the rest. Let us see that. It has got, the third position has got removed. Let us check. The third position is 2. It has got removed. See, it is 100, then 9, and then directly 5. It has jumped to, and then 7, then 130 and 6. Okay, because the ones are replaced with 100 and 3 is replaced with 30. All right. Okay, now coming to here. See, and you can combine this which, just look at here, you can combine this which too with, like if you want to remove every element that matches a condition, say every value equals to 1, you would write something like this, okay? Something like this. You want this value of 1. Here, look at this vector. If you look at this vector, you are seeing the values 1, 3, 2, 5, 9, 5, 3, 2, 1, 7, 3, 9, 7, 1. So you are watching that some digits are frequently written, right? It has got multiple values, multiple times it is written the same value. Now I want to do what? I want to remove this one in every position where it is there. So where are the positions? This is position 1, position, I don't know, this one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12, 13, 14, 15. So these positions 1 should be removed, and for that what was the command? It was the which function, right? Which function used to give us the positional values, and here I am keeping the minus sign, then it will remove those positions. Okay, so removes every element equals to 1. Let us see if it works. First I am writing the vector, and then I am giving the command that what I want from it. I'm calling it. Now see here, can you see any value of 1 here? You do not, because here we have given the command to remove every element equals to 1. So you are getting to understand how these commands work, right? Okay, so that is all for segment 5, and now coming to segment 6. This is basically sorting of a vector, okay? Now this sort function arranges a vector's elements in order, basically ascending and descending order. And how do we do it? If I write only sort x or sort z, here I have written because I am taking the variable name to be z. So sort z is basically ascending order by default. It is by default. If you do not have to write any other command. But if you want to be decreasing, then you need to do what? Sort z and then comma decreasing to be true. Okay, this will be decreasing order, descending order, decreasing order, whatever. Okay, now this decreasing argument is a logical value, true or false, that decides the direction. By default, as I said, that R assumes decreasing to be false, which basically means ascending order, right? So let us see how these things work. First, I'm calling out the variable, I'm calling out the vector which I have written here. Now I want to sort it in ascending order. For that, I do not have to write anything like this. I do not have to write decreasing equals to false because that is by default. Let us see. Yeah, can you see that here it has been written in ascending order? Now I want it to write in decreasing order. For that, you need to write decreasing to be true. And as you can see, I have written here true in uppercase letter because that is the standard method to write in R for true or false. That is logical operators, right? Okay. Now I want to see that if it really works for if I write decreasing to be false. Like I do not need to write, but if I write, then does it work? See, it is still working for sort z and sort z decreasing equals to false. Now this is like explicit, okay? Now as I was saying that decreasing logical argument true or false that is written. Okay, now coming to segment 7 that is reversing a vector. Now rev whatever the value here that is z here because we are taking the vector z here now, whatever the function whatever the variable name will be written in the open bracket, right? So ref open bracket simply flips the entire vector. Okay, first becomes last, last becomes first. Super handy when you just want the elements in the opposite order without actually sorting anything. Okay, so this is very useful. So let us see if it works. If I want to get the reverse order, see what was our original value. This is our original values. Now I want the reverse elements. So now here the last will be first. Okay, so one the how will be the order 179 371 235 95231. Like this only it is written here, right? So that is basically reversing a vector. Now coming to ordering a vector. Now this one confuses people at first. So let's slow down here. Okay. Order function does not rearrange your vector. Instead, it tells you the sequence of positions you would need to pick elements from now to get them in sorted order. Okay. So if your smallest value is sitting at position 4, then order will tell you 4 first. If the next smallest is at position 2, then it says 2 next and so on. Okay, so order x will give you basically the ascending order of positions. I have written in block letters because this is very important to understand that I'm not getting the values here, I'm getting the positions here. Okay, let us see if it works. First, I am taking the variables. I am taking the variable x and I am taking the values 10, 20, 30, 15, 40, and 18. Now I am taking order x. It gives us the position, ascending order of position. Can you tell me which is the smallest number here? It is the 10, right? So the first position is given in the first value, then second is 15, so it will be what 4 position, then is 18, then it is in 6 position, then 20, then 2, like this 2 3 and 5. Okay, 40. So basically order of x means ascending order of position, and next is order of x decreasing equals to true. It means what? As descending order of position. Same like the command, the syntax is almost the same which you want for the variables, which you want for the commands. Here just you need to remember what is sorting, what is ordering, and next we have the ranking. You need to remember the differences between those. Okay, okay, so let us see the decreasing one. See, it will now give me the decreasing order of the positions. Okay, now that is what I have just told you. It will give you the sequence of indices, that means the positions. Just as I was saying that you need the ranking of vector, and this is the next segment. See, segment number 9, this is the ranking of a vector. So rank function gives every element in your vector a rank. Okay, it will just give a rank based on its relative size compared to the others. Smallest gets rank 1, next smallest gets rank 2, and so on. Now this is different from order. Let me explain you why. Because order tells you the positions in sorted sequence. It will give an order, that is like order function is this is so ironical of me saying this. Order is giving you the positions, okay, in a sorted manner, but here ranking will not give you that. Rank function tells you each element standing relative to the rest. Let us see how it happens. See, for I'm taking this variable name x and I'm taking the vector here 532179. If I want the rank x, it will give us the rank of each element related to the rest. Smallest value gets rank 1, next smallest value gets rank 2. That is what I've said. Now I am taking the rank. See, what is the rank of 5? It is 4. Rank of 3, it is 3. Rank of 2, it is 2. Like that, 1, 5, and 6. So it is not giving a sorted sequence. It is not giving in a sequential manner. It is just giving what is the rank of this. The smallest value is 1, right? So what is the position? 1. 1 for 1, it is 1 only. That is the smallest rank. Next is 2, so it will be 2 only. Next is 3, it is 3 only. The next smallest is 5, so it is the position 4. It has given position 4. I mean the rank 4, the for 5 the rank is 4, the rank is 4 given here. Then it is 7, so fifth rank is given to 7, and then sixth rank is given to 9. So this is how ranking works. All right, now I can see this is the last one for today, searching for multiple values with this function percentage in percentage. So this lets you check whether values exist inside a vector, and it works beautifully for checking multiple values at once. Now look at here. I am taking a vector here, x. I'm taking the variable name to be x, and I'm taking these values, okay? Now, what I want to do is that x percentage in percentage and see 20 and 18. 20 and 18. Now, what does this do? Let me take 10, 20, okay, 20 and 18, whatever. It will check each element of x and then return true or false depending on whether it's found in that list. If it is in the list, then it will be what? True. If it is not, then it will be false. Let us check what happens. Okay. So what happens is that 20 and 18, is this 20? No, this is false. Is this 20? Yes, it is true. 15 false, 30 false, 40 false, but 18 again true because I want 20 and 18. Returns true or false for each element. Now look at here. I am just keeping this in the squared brackets. That is a third bracket. That means that I am trying to index it. Indexing means it will return the actual matching values. Let us see. 10, 20, and 18, it has got the actual matching values. So what does this is to actually pull out the matching values, not just true or false. If we wrap it in indexing, then we will get the actual values. Okay, so basically, yes, that is all for today. Yes, we have started from here. And that's a lot covered today, right? We went through creating vectors, indexing, logical checks with which function, modifying and removing elements, sorting, reversing, ordering, and searching with percentage in percentage, right? Now, what I want you to do is that practice these on your own vectors. Genuinely, this is one of those topics, where hands-on experience or hands-on practice makes it click 10 times faster and than just watching. So yes, please practice more and more. You can take help from my video, of course. And yes, in the next episode I'm going to build on this even further. Like, subscribe, and I'll see you in the next one. Okay, thank you for watching.